Okay, so this is week 9, transportation engineering, gate previous year questions. So today we'll solve first question just to revise our concept a little bit. Then we'll get into traffic engineering. We'll look at Webster's formula and weaving ratio. These are some of the topics that are very common actually. So we'll look at those topics. So let's start. Yeah, so one thing I have noticed is that many of you guys don't know when the session is postponed, and you still join the link and then you keep on waiting. It wastes your time, and it makes me also, feel bad that you are not able to join the session. So here I will show you that using the link, that we have been given in the NPTEL. So you can actually check when the meeting is postponed and when it is going to be. So I think you are all familiar with this web page, web interface. So if you go to the civil engineering portion and then you look at the sessions, you will be able to see that when the session is postponed. So since the last time Sunday session was postponed to today, so they have actually made it highlighted it on this particular calendar or something, and you can actually see if the session is postponed or not. So when you are joining the meet, try joining through this site or this portal so that you know whether today there is a session or the session has been postponed. See, sometimes we'll have some other commitments, so we cannot always come on the same time. So I hope you understand and you will follow this. Okay, guys, let's start. Okay, so this is our first question, GATE 2009, question number 14. It is related to the summit curve, summit and valley curve. Let's see which one it is. A crest vertical curve joins two gradient of plus 3% and minus 2% for a design speed of 80 kilometers per hour, and the corresponding stopping side distance is 120 meters. The height of the driver's eye and the object above the road surface are 1.2 meter and 0.15 meter respectively. The curve length, which is less than the stopping side distance to be provided, is. So this is very interesting statement, that is given to us. That is the curve length, which is less than the stopping side distance. So no matter what actually you will get the value for L, you have to tell here the value of L which you get after assuming that the length of the curve is less than the stopping side distance. So you remember we have two formulas to calculate the stopping side distance in case of, sorry, in case the curve length in case of the summit curve, that is L is equal to ns square by root under, sorry, root under 2h plus root under 2h square when L is greater than SSD, and L is equal to 2s minus 4.4 divided, or 4.4 actually is a standard when nothing is given to you, no, neither the driver's eye height or the object height, but basically the original formula is this. So this is the formula we use when L is less than SSD. So what they have told us is they want the length of curve when the length of curve is less than the stopping side distance. So we'll see how to solve this question. So first let's see what is the value of this. Is it 4.4 or is it something else? So we have capital H is equal to 1.2 meters. We have small h is equal to 0.15 meters. So the value of root under 2h plus root under 2 small h square is, let's calculate that. So yeah, root under 2 into h 2.4 plus root 2 into 0.3 root into 0.3 and then the square of that. So it's actually coming around 4.4 only. So this is the standard case. Okay, now let's calculate the value of L. L is equal to 2s minus 4.4 divided by n. What is n? N is actually in absolute value, means percentage divided by 100, and it is the difference of the gradients between the two, the two curves that is joining, that the curve is joining, the two roads that the curve is joining. So we have one that is plus 3 and another one that is minus 2. So this is plus 3 percent and this is minus 2%. N is nothing but 3 minus minus 2, that is 5%. So we have been given the side distance. So the S in this case N is going to be 5 by 100, and the S, that is the SSD, stopping side distance, is given to us as 120 meters. So this is 120 meters. So let's put in the value, and 2 into 120, 240. L is going to be 240 minus 4.4 divided by 0.05. That is 152 meter. Now notice one thing here, that we are asked what is the value of the what is the value of the curve length which is less than L, and we also use the formula which is giving us the value of curve length which is less than the stopping side distance, but the value that we are getting is 152, which is obviously greater than 120. So 120 meter. So this is, conventionally, when we are solving a question and when we are asked, see what is the curve length. When you solve these conventional questions, definitely you are not going to give the answer as the length of the curve as 152, because the initial assumption to use this formula was L is less than SSD. But here we are getting L is greater than SSD. But in this particular question, for some reason, it is said that you have to give the value of curve length which is less than uh, you know which is less than stopping side distance. So we can only, the best we can do is use this formula and give the value of curve length which is which is coming from a formula which corresponds to L less than SST. So the answer to this question is 152. But what will be the correct answer? Let's say, so since L is clearly here greater than SST, we have to use the another formula, that is ns square by 4.4. So n is 0.05 into 120 square divided by 4.4. So in this case you will get the value somewhere around 163 meter, which is correct for our hypothesis for using this formula, that L is greater than SST. Now, this is also one of the options in this question. So, if you didn't read this question carefully, you will make a mistake in solving this question. So, always read the question till the end, right? Because in the end, this formula is, this condition is given to us, which will prompt you to give the wrong answer, even if you know the concept thoroughly. Okay. Now, let's go to the next question. So, GATE 2009, question number 48, same paper. The three-phase traffic signal in a given at an intersection is designed for flow shown in the figure below. There are six groups of flow identified by the number 1 to 6. Among these 1, 2, 3, 4 and 6 are through flows, 2 and 5 are right turning. Okay, so 1, 2, 3, 4, 6 are through flows, 2 and 5 are right turning. Which passing scheme is not feasible? See, when we are going in a traffic intersection, people have to cross. Some people want to go straight, some want to go left and right. So we have to put there the traffic light so that one at one time non-conflicting traffic will go than the other. So we can avoid collision. So what does it mean when it says that not feasible? It means that in one of these combination choice we are going to see some kind of collision. So let's try to identify if there is a collision. So I have put another, you know, plot here. So let's see if we see any collision. I think I should have put this also. So let's see here itself, maybe because I didn't put this particular table there, so we won't know which combination is having which flow at the time. Okay, so P, let's look at P. 1, 4. 1 is going, 4 is going. So the easy way to do this is just to draw the lines, and if you see if there is an intersection. Not the merging intersection, but just direct conflict. Okay, so this is what we are looking for. Okay, 2, 5. So this is one time this will go. Then we have 2, 5. 2 will go here, 5 will go here. We have 3, 6. 3 will go here, 6 will go here. Okay, very good. We don't have any kind of conflict in these three phases. So P is good to go. Now let's look at Q. 1 will go here, 2 will go here. No conflict in this phase. 4 will go here, 5 will go here. No conflict in this phase. 3 will go here, 6 will go here. No conflict in this phase. See, we have to look at conflicts within the phase, not like between two phases, not between these two phases, but within this phase. Okay. So Q is also fine. Now let's look at R. We have two, let's say, okay, this person is going right or left, we don't know. Let's put both. We have 2 and 5. Okay, no conflict here. And we have, what is in the second phase? 1 and 3. Okay, so we found out the conflict. See, 1 and 3, if they go at the same time in a single phase, they are going to have a conflict. We'll see a lot of accidents actually. So this is definitely not true. Let's, for safety, for completion, let's look at S also. S is having 1 and 4. Okay. 2 and 6. Okay. And 3 and 5. Okay. This is also not showing any conflicts. So S is also good. So the only uh, choice combination that is giving us problem is R. So we will say that R is not feasible. So the answer is C. Okay, this is a simple enough question. I think you will all be able to understand and appreciate how much thought is put into designing the traffic signal. This is just a 4 by 4. If we have lot of clover leaf are there, you remember you would have seen these kind of intersections which have the cars rotating. They don't even need the traffic sign because all the traffic is moving every time. There has been a lot of thought put into these designs. Okay, so a little bit sidetrack we went. No issues. So this is the second question, pretty easy question. Now let's look at some of the questions, which I feel that are actually, not difficult, but sometimes we hesitate to go to these questions because we are not able to understand what is the logic behind these questions. So one of the example for me is I always ran away from weaving ratio, like how to calculate weaving ratio. I always ran away from this type of question. So but I thought today that let's try to look into this more carefully and try to teach you guys also. In the process of teaching you guys also, let me also learn what is going on in this question. Okay, so what is weaving ratio? You remember, all of you may be remembering that B is equal to B plus C and A plus B plus C plus D. Some kind of formula is given to us where we are told that B plus C is the weaving traffic and B plus C is the total traffic. We are not going to look at this formula. We are going to solve this, conceptually and with a little bit of a trick so that we stop getting scared by this formula. Okay, so when you are asked weaving ratio, remember that weaving ratio is going to be for this kind of intersection. So they will ask you, let's for example, you see that in this question they have asked weaving ratio for the section west to north. So the traffic going from west to north, okay, for this particular section they have asked. Similarly, they will ask north to east, east to south, and south to west. This is the possible locations where the weaving ratio is going to be asked to you. Okay, and what is weaving ratio? Basically, weaving ratio is nothing but P is equal to weaving traffic divided by total traffic. So first of all, what is total traffic? Total traffic that will pass through this section, that is your total traffic, and the weaving traffic is the traffic that is going to weave through this in some way. We'll try to see a trick which we through which we can easily identify what is the weaving traffic. Okay, so let's start. First, let's look at the total traffic. So let me use another pen. So we'll see which are all the traffic or which are all the possible ways in which a vehicle is going to cross this particular section. I'm going to use blue for our west to north. So we have to look at predominantly these two. These two also, some of the traffic from these two also will come, but let's start from the west itself because we are asked west to north, and in our country we follow left-hand drive. So this is going to be the starting point. If we choose this as a starting point, it is going to be easy for us. Okay, yeah. So let's start. Let me increase the width a little bit. Yeah. So from west, a car can go left, car can go straight, but it will have to go through the rotary, and then it can go right also. In all these three cases, it is going to pass through this particular section of our, that is the weaving section. So let's draw this here. So we have car going left, car going straight, and car going right. Okay, so we have these three. So these three values are from west to north 400, from west to east 505, west to south, that is 410. Okay, good. Then what else can go here? Let's look at north now. Let me change the color of the pen. Let's look at red. So north, the car can go left. So this is this. Then it can go straight. It will be this, and it can go right. It is this. So in all these three cases, the traffic is not actually going through our this section. So now no traffic from north is going to go through this weaving section. Okay, so let me retain this red color, or let me change itself. Let me change the color. Okay, now let's look at the east. If from the traffic east they want to go left, they will go directly without going to this. When they want to go straight, they will go again without getting to this section. But if they want to go right, that is if they want to go north, they will have to come here, rotate the whole rotary, and then go to this. So the traffic that is going from east to north, that is going to go through this view of west to north, and that value is given to us as 600. So 600. Okay, good. Now let's look at the traffic that is going to go from the south. So let us again change the color. South, if they want to go left, easily they can go without going to the weave section. But if they want to go right or if they want to go straight, they have to use the weave. So if they want to go straight, they are using it. If they want to go right, they are using it. So south to north, they are using the weave section. So 350. South to east, they are using the weave section, that is 370. So we have identified these, is the sum of these is going to be the total traffic. So let's calculate that. So we have the total traffic as 400 plus 505 plus 410 plus 600 plus 350 plus 370. What's the value? 400 plus 5, 5 plus. That is 2635. So let's write the unit. Maybe we can write PCU per hour. That is the passenger car unit per hour. Now the trick is how to identify weave traffic. That is the if there is any difficult part in this question, this is the most difficult part. So here is a trick that I learned from a YouTube video. I don't know, I don't remember which YouTube video, but a very nice trick that this person, the professor, they told that if we are looking at the traffic, weave section or the weave ratio between west to north, okay, then weave traffic is going to be all the traffic from west except traffic going from west to north. So all the traffic that is coming out from the west direction except the traffic that is going to the north direction from west direction, that plus all the traffic coming to north except from west. So in both the cases we have to ignore this particular left turn that you are taking from west to north. Except this, all the traffic going from west and all the traffic coming to north are going to be your weave traffic, is going to be your weave traffic. So let's see what is that. So all the traffic going from west, so that is west to north, west to east, west to south, but we don't have to consider west to north, so this is removed. So west to east plus west to south. Now, all the traffic going to north, but not from west. So all the traffic going to north is west to north, east to north, south to north, but not, we have to again ignore the west to north. So we have east to north plus south to north. So what is this? Weave traffic is your 505 plus 410 plus 600 plus 350. So what is the value? 505 plus 410 plus 600 plus 350. We have 1865. And weave ratio is nothing but, again, weave traffic divided by total traffic, that is 1865 divided by 2635, and that comes out to be 0.7077, that is nothing but 0.7, and that is your answer. So this is a nice little trick that I also learned, in order to teach you guys, and I from now on I will not be afraid of this weave traffic question. So once again, I'll write it more clearly. Looking at traffic from west to north, or the weave ratio we want to calculate for this, then weave traffic is nothing but all traffic from west except that going to north plus all traffic to north, or let me write here n, except that coming from west. And surprisingly enough, this particular formula is applicable even if you have a 5-hand rotary. So even if you have traffic coming from, five directions, one, two, three, four, five, this formula you can use to get the weave traffic. And total traffic, it's pretty simple. You can just draw the lines and see which are all the, traffic lines are going from which section to which section. Okay, so that is related to your weave ratio. I hope you understand and appreciate the trick, because I think I put a comment also to that particular video, that thanks for this particular trick, that particular original, from where I learned. It's a very neat trick. Okay, let's move on to the next question. What is the formula for the optimal signal cycle according to Webster's method? So we all know, when we are standing in a traffic, we get to go only when the signal for us is green, not before that, right? So how is that designed? That is designed, maybe they have improved, they are using improved method right now, but previously they used to design it using Webster method. Maybe it is modified by some logic right now. So that Webster method will give us the cycle time. What is the cycle time? It is going to tell you that if you just got green, after how much time again you are going to get green signal. Basically just the cycle of the combination of green and red for different phases. So in this question, it is asked, what is actually the formula for that optimal cycle time? So I think you all must be pretty familiar with this. It is very basic formula that we all should know if we are preparing for GATE, because simply direct formula based questions will come from this method. So it is nothing but C is equal to 1.5 L, that is the total loss time, plus 5 divided by 1 minus Y, capital Y. That is nothing but the ratio of the um, saturation ratio of each phase. So Y1 by S1 plus Y2 by S2, so on. You know how many phases you have based on that. L is nothing but total loss time, that is 2N plus R. If you are not given, the uh, division for this, two division for loss in each phase, you are to take 2 seconds loss for each of the phases of traffic, and you multiply the number of phases with 2 seconds, and then you add the a total red time or all red time, and you get the total loss, and you use this to get the uh, Webster's method optimum signal cycle. And then you use this, from this optimal signal cycle, you use the ratio that you calculated, the saturation flow ratio, to get your green time for signal for phase 1, green time for phase 2, and so on for how many ever phases you have, right? So this is the Webster's method. So for this particular question, the correct answer is going to be 3. Okay, now let's look at a question related to Webster method, just to solidify this concept that we have seen just now. So this is a question. The average normal flow on the intersection of road A and B was found to be 400 PCU per hour, 500 PCU per hour, while the saturation flow on the intersection is 1600 PCU per hour and 2000 PCU per hour, respectively. Take the all red time to be 16 and then identify which of these statements is correct. So what is given to us? So phase 1 is let's call them phase 1 and phase 2 instead of road A and B. For or maybe we can call road A and B itself, because the saturation flow is given for road A and B. Yeah, let's call them road A and B to avoid any kind of confusion. So for road A, the traffic is 400 PCU per hour. For road B, the traffic is 500 PCU per hour. and the saturation flow for road A is 1600 PCU, and saturation flow for road B is 2000 PCU per hour. So according to our Webster's formula, so first let's calculate this C, the optimal cycle time, that is nothing but 1.5 into L plus 5 divided by 1 minus capital Y. So for that we need to calculate L, that is the total loss time. No specific information is given to us regarding the loss in each phase of the traffic. So we are going to take the conventional formula, that is 2n plus r. Since we have two roads and supposedly we are given two flow informations, we are going to assume that okay, there are two phases. So 2 into 2, n is equal to 2 plus r is 16. So we have here 20 seconds. Total loss time, capital Y is nothing but 400 by 1600 plus 500 by 2000, that is 1 by 4, 1 by 4, 0 0.25, 0 0.25, 0 0.5. So the value for C is 1.5 into 20 plus 5 divided by 0 0.5. 1 minus 0 0.5, that is 0 0.5. 1.5 into 20 is 30 plus 5, 35, divided by 0 0.5, that is multiplied by 2, we have 70 seconds. So I think we have calculated most of the things. Let's see what are all the conclusions we can draw from this. So what is the first option? First option is, that is a sum. Okay, I think I did mistype this. This is a sum of flow factors for road A and B is. So it is just asking the value of y. So it is saying the value of y is 0.5. That is true. Second, optimal cycle time per as per Webster method is 70 seconds. That is true. Third is effective green time for A. So we'll calculate that. And total lost time in the cycle is 20 seconds. We calculated L. It is asking L. Okay, that's true. Okay, so let's try to check whether this option is correct or not. So we have to calculate the green time for A. Let's calculate the green time for A and B both actually. Okay, so what is green time? It is nothing but the ratio of your saturation flow divided by the y, kept total y. So nothing but y1 by s1 divided by sigma yi by si. So this is just nothing but y1 by s1 plus y2 by s2, and keeps on going till how many phases you have, multiplied by c minus l. So we have our y1 by s1, it is 1 by 4, and capital Y is nothing but 1 by 4 plus 1 by 4 is 1 by 2. And we have 70 as C and L is 20. Then green time is 1 by 2 into 50, that is 25 seconds. So it is not 30 seconds but 25 seconds. So this option is incorrect. And the same is for, so this is green A. The same is true for green B because their ratio for this Y1 by S1 was same. So green B was also 25 seconds. Okay. Yeah. So I hope, you're able to understand this, how to use the Webster's method, and how to proceed and calculate all these things, because from Webster's method the questions will come directly. This is just a formula based method, and I also hope that you are able to understand and appreciate this weaving, because I know I thoroughly enjoyed calculating the weaving ratio for using this concept, using this trick, right? So I hope you understood, and that's all for today's session. I know that because of these so many postponements in the session, this time no one was able to join. But look, initially itself, during the start of the session, I have shared with you the location from where you can actually see whether we have the session today or is it postponed or something like that. So uh, I will request you guys to look at that every, not every day, but let's say on Saturday or Sunday morning, to check whether we have a session on that particular day or not, right? Because we have some commitments, so it is not always necessary that we will have a session on the Sunday itself. Sometimes I have to postpone that session, and because sometimes some paper correction will come, sometimes some field visit will come, so we have to do all those things other than our research and this NPTEL TA duty. So I hope you understand, and let's hope that we'll meet again on Sunday. Thank you.